Hey everyone, today we're going to be looking at the first part of our Chapter 11 practice test. Now this practice test is going to be for chi-square distributions in particular. And we're going to start off by looking at a chi-square distribution goodness of fit test. So let's check it out over here on the next screen. So for this problem, we have drivers born under the astrological sign Capricorn are the worst drivers in Australia, according to an article that appeared in the Australian newspaper The Mercury, 1998, October. This statement was based on a study of insurance claims that resulted in the following data for male policyholders for a large insurance company. So we have the astrological signs and the number of policyholders for each of those signs. And we notice right over here, Capricorn has the most policyholders just by taking a look at that. So, assuming that it's reasonable to treat the policyholders of this particular insurance company as a random sample of insurance drivers in Australia, are the observed data consistent with the hypothesis that the proportion of policyholders is the same for each of the 12 astrological signs? So, A, enter the number of expected counts under each observed counts. So what we're saying here is that if we believe that all the astrological signs should have the same number of policyholders, how many policyholders should that be? Going to our calculator or your spreadsheet if you like, we can take a look at that. So I've gone ahead, I've put all of those policyholders under a list. These are all in list 1 here. Those are all of the policyholder amounts. We can see right over here, this is our Capricorn sign. So how many policyholders do we have? You can add that together with your spreadsheet if you're using a spreadsheet. Here on the TI-84, we go to list, and then we sum number 5, and then we're going to sum together all of L1. That tells me that this is 460,168 drivers. Well, there are 12 astrological signs, and if we divide that equally, that's 38,347.333. Go ahead and notate that on your list, and that takes care of part A. Now for part B here, we're going to write the null and alternative hypothesis. The null hypothesis for all of these chi-square goodness of fit tests is that the claimed expected distribution is true. So we needed to write that expected distribution somewhere on our paper. Alternatively, we would say that the claimed expected distribution is not true. So this is always the same thing for every goodness of fit. The null hypothesis is the expected distribution is true. The alternative hypothesis is that the expected distribution is not true. Actually, if you think about it, that's going to be the same for every chi-square test. Every chi-square test has as the alternative hypothesis that the expected distribution is not true, although the consequences are a little bit different depending on the test that you're using. Next, we're meant to state and to verify all the conditions for carrying out the inference procedure. The name of this procedure, since we're taking a look at one variable, or one sample and one variable, it is the chi-square goodness of fit test. Now, I know it's kind of confusing because we say one variable, and yet we have Aries, Taurus, Gemini, Cancer, Leo. But really, what we're looking at is one variable, and that variable is astrological sign. 12 different categories in that one variable. So try not to get too confused with that. That one variable business doesn't state how many categories. Now, the name of the test is that, so let's get to our conditions. Firstly, the sample must be a random sample, and if we take a look at the question, we see the words, where did it go? random sample of insured drivers. So we're going to write that in there in a quote so that we know that that came from the actual question and we didn't just make it up. Second condition, all expected counts need to be greater than 5. And that's not a problem because all of our expected counts are 38,347. When we're doing this academically, you're going to have to say that all expected counts are, and then what number that they are, or greater than. And then you want to have a reference to the expected table. Now, when I say expected table, I don't mean the table that's expected to come. I mean the table of expected values. And if you've written them like I've told you to, that shouldn't be a problem. But you do have to write down the expected values. Letter D. So for this one, we're supposed to determine the test statistic, the degree of freedom, and the p-value. Now, some of these are a little bit easier than others. The degree of freedom is just a number of categories minus 1. Of course, that's just 11. Now, the chi-square test statistic, we're going to write down the general formula here. The specific formula. It's the sum of all the expected, observed minus expected, divided by expected. Now, we have 12 categories, so that could get pretty lengthy. For the sake of this video, I'm going to go ahead and I'm going to put all of them in here. We're going to start off with Aries, and Aries has a observed value of 37,926. From that, we're going to subtract our expected value. I'm actually going to round that down since I don't think that 0.33 is going to matter. And then I'm going to square it. Now, if you're not comfortable with rounding at this point, then by all means, leave all the decimals. You're not going to hurt anybody. And then we're going to divide by that expected value. So that's all the work we needed to do for Aries. Let's do Taurus next. I'll set up that fraction, substitute in our observed value, and we're done. Let's move on to the next category. Set it up, substitute the observed value, substitute the expected value, and then move on to the next fraction, and then move on to the next fraction, and then the next one, and then just keep on going. Now, as we've seen many times before, writing down this work, is what we're calling it, the work here is just kind of for show, really, because we're going to do all the calculations on the calculator. We just want to have the opportunity to show the reader that we know how we would have done this had we had to resort to, paper and pencil mathematics. So I highly doubt you're going to get something with 12 categories. Usually the most I see is 8. But, be prepared for that. Let's go ahead and grab our calculator. And in our calculator, we're going to go back to our list. And we're going to put our expected values over here in list 2. This is usually the best way of doing this. So we're going to go ahead and just write down 38,347.333. We're going to go ahead and put that on every item in list 2. Remember that my observed were in list 1. My expected are going to be here in list 2. So I'm going to fast forward and do all of them. And that pretty much does it right over here. We have put all of our expected values into list 2. Now from the home screen, we're going to go ahead and calculate the actual chi-square test statistic, and we're going to do so with the following. We're going to go to the list command, and we're going to look for sum. Sum is where we add a bunch of things together. There, I see it. It's number 5. So we're going to sum, and what we're going to sum is the observed, which were in L1, minus the expected, which were in L2, square that, and then divide that by L2. Now, if you're more comfortable using the fraction bar here, that's totally fine as well. Doesn't matter. And we're going to add that together, and this number right here, that is our chi-square test statistic. So we're going to write that down in our paper now. Okay, so that's our chi-square test statistic. The last thing we're supposed to write here is going to be the p-value. As a reminder, the p-value is always the probability or the proportion of the chi-square test curve that's greater than our test statistic. So we write down probability that chi-square is greater than 8,216.456. We'll go back to our calculator and we'll use the chi-square CDF. There it is at number 8, chi-square CDF. And our lower is always going to be our test statistic. Our upper is always going to be whatever large number we put in our calculator. I tell all my students to put 1E99. Put in your degree of freedom, which is 11. Paste that and push enter. There you go. Your chi-square test statistic for all purposes is 0. Back on our paper, we will write that the p-value is equal to 0. And finally, we're going to make our decision and state our conclusion. If you're in my class, then you know that we have a ready-made conclusion for you. Since the p-value is either greater or less than alpha, the data either does not or it does support the alternative hypothesis. Let's see, a p-value of 0 is definitely less than any alpha. So that means our conclusion is that the data supports the alternative hypothesis. We'll just clean this up a little bit. And so now we need the alternative hypothesis in context. Let's get that alternative hypothesis. Is that the claimed expected distribution is not true. We do need to put that in context. So hold on for that. And in context, that would mean that the proportion of Australian driver policyholders is not the same for every astrological sign. Now remember that in AP Stats, the context is king. So if you write a conclusion here that doesn't have the correct context or doesn't have context at all, you will definitely be hurt on your score. So that takes care of question 1, and we'll see you next time for more Chapter 11 test.